Our next presenter is me, Daniel Kornaś. As a graduate of Aviation University of Science and Technology with a master's in electronics and telecommunications, I've always been fascinated with the latest and innovative technologies emerging. I have started my career here at Nokia 5 years ago as a software manual test engineer. So I didn't start my career as an artificial intelligence right away, but of course, with the help of my very helpful managers and having the opportunity to evolve at Nokia, I was able to start some projects with artificial intelligence. And so a couple of years back, an initiative was introduced at Nokia that said that artificial intelligence and machine learning is the way to go and the future. So thankfully, I was able to start some projects with machine learning, and here I am today as a machine learning technical lead. And so I'm absolutely fascinated with the latest technologies, especially artificial intelligence, automating anything that and everything that is possible with the help of a click of a button. So for today's presentation, I would like to be presenting how to use AI and NLP techniques for issue, ticket, and automation. So let's dive in. So before we get started, I kind of wanted to divide this presentation into two main parts. The first part is an introduction to AI, kind of to give a refresher just in case someone forgot what exactly this artificial intelligence is, where did it come from, the history behind it, and later we'll go into more details of what exactly this machine learning is really. And then later for the second part, we'll go into a little bit more details, specifics in regards to a certain project that we have been working on here at Nokia, which is using AI for ticket automation. And so we'll talk about what are some natural language processing, how exactly do you do this NLP, which is natural language processing for short, and what are some next future kind of steps to look for in our project. So let's get started. And so let's start off with a very interesting question that everyone always asks is, what exactly is this artificial intelligence? We see this everywhere where we go on the internet. Everyone's talking about it. But what exactly is this artificial intelligence? Well, the first thing really that comes up to mind is Terminator, Skynet, end of the world, robots walking around, dominating the world, the Matrix, maybe for others, it could be Power Rangers or Transformers. That's pretty much the very first thing that comes to mind. But really, it's not exactly that. Only movies really portray it, but we have a far way to go before we really see the Terminator. Unless if you live in California, then maybe you've seen the Terminator walking around somewhere. But other than that, we don't really have to worry about that. So, but what exactly is this artificial intelligence? Well, AI is the theory and the development of computer systems that can perform tasks that normally require human intelligence. So normally something that is a human needs to do, then a computer program will be able to do it without that human intervention. That's basically the common baseline, the theory behind what exactly this artificial intelligence really is. And so today, AI is almost everywhere we go, in everything we use, in businesses, in governments, and absolutely everything, which we'll talk about a little bit more, get into later. Now, just to be clear, artificial intelligence is more of an umbrella term. It's a general term really used because artificial intelligence breaks down into very many subcategories. And some of these subcategories are machine learning, natural language processing, speech, and vision. And of course, machine learning and NLP are kind of the main topics that we're going to be talking about really today. So again, artificial intelligence is very an umbrella term. It's kind of used interchangeably with machine learning, but more or less, we're talking about the same thing. But of course, just to be clear, it's just an umbrella term, and then we get more and more specific down the line. So just to be clear. Now, let's ask ourselves the question, where did AI come from? Well, as popular as it may be right now, it actually didn't start off recently. It's actually a very old topic. It kind of started off in the 1950s, where basically a group of researchers kind of came up with this crazy idea of, hey, why don't we recreate the human intelligence within a machine? Okay, sounds like a great idea. So they got together, started to think, okay, how exactly can we really do this? Well, two kind of main groups really, or two main ideas, you could also kind of say it kind of came from these discussions. The first one is called the rule-based group. Now, the rule-based group were researchers who wanted to hard code everything into a computer and say, this is artificial intelligence. So if X, then Y. If it's a red light, then stop. If it's a green light, then go, and so on. And so they hard coded all this information into computers so that a computer would be able to do whatever the task was needed. Except it was nice at first, but once they got into a problem that a computer never really saw, then they had to rush to the experts, ask them, how exactly would you do this? Write it all down, go back to the lab and hard code everything again so that it has the latest and newest information. So it was kind of time consuming and maybe not fully practical. Now there's the second group, which was called the neural networks group. Now the neural networks group, they wanted to recreate the human mind. And when I mean recreate, they wanted to reconstruct the neural networks that are actually within the human brain, exactly how they are. And so when you learn something new neural networks are created within the mind and so on. And so being this ability to learn based on this neural network. And so that's what they wanted to recreate, except it wasn't that easy. And so at first, in the beginning of the 1950s, neural networks were very popular. Everyone loved the idea, that seemed like the way to go. But in the 1969 about time era, the rule-based group basically said, forget about it, neural networks. You can't really do anything with it right now because the biggest problem with neural networks is you need a lot of data and you need a lot of computing power. And so during the 1950s, none of those things were really available. So neural networks were just not practical, and so they were basically kind of left and forgotten. And we started the first so-called AI winter. So basically, it was completely forgotten of what exactly this neural networks really were. So researchers were mainly then focusing on the rule-based group and hard coding all these rules. Then somewhere in the 1980s, between 1990, the neural networks group kind of had a few moments of glory. They had a few projects that they were able to create using the neural networks, but again, nothing really too much promising. They got a pat on the back and saying, good job, but no, it's still not good enough. And so in the 1990s to 2000, the second AI winter basically reappeared, completely forgetting about neural networks altogether. But everything soon changed. See, three kind of main factors really reappeared around the 2000 area, and that is when computers and the internet really started to appear. And the first thing is data. Once the internet started to appear, tons of data started to be generated because everyone started to have computers at home, and then everyone started writing blogs, articles, uploading videos. Tons of information started to appear on the internet. So now we had tons of data to train our models. So we have the first criteria fulfilled. The second one, computing power. Computing power was so cheap now that everyone were able to afford computers at home. And so that allowed to have much more powerful computers for researchers as well. And so with the help of computing power, we were able to actually calculate all the various calculations needed for neural networks. And the third kind of most important thing was the invention of deep learning. And this was created by Geoffrey Hinton. And this I'll explain what exactly happened with this deep learning. And so there was a competition. Usually every year it was hosted. And this contest was about a computer vision contest. So basically a computer had to classify a data set of various images. And so year after year, researchers, people try to create some kind of model that was able to do this task, except unfortunately they were gaining about 30%, 40% accuracy, so they weren't really great. However, at the time that seemed like the highest accuracy rate until Geoffrey Hinton and his research team actually came and they first introduced the first deep neural networks. And when they introduced this, it blew everyone out of the park. The deep neural network had achieved around 80% accuracy, which completely demolished everyone. And thanks to this deep learning, neural networks started to be actually very useful and practical and actually started getting really good results. So after this deep neural networks were introduced, it was a huge boom for neural networks. And so because of that, new technologies started to emerge. We had deciphering human speech, translating documents, generating text, summarizing text, recognizing images, identity fraud, making lending decisions by banks, and so on, and many, many more. And even as a fun fact, recently I've seen ironing. So the machine that you use to straighten out your clothes and iron, that even has artificial intelligence. And they they explain that this iron has a camera. It can see what kind of material you have, and based on the material it classifies, it sets the perfect temperature for your ironing, so you never have to worry about setting the right temperature for your iron. So even in simple devices such as that. So it's quite amazing to see artificial intelligence really everywhere. So now let's go a little bit more specific and talk about what exactly is this machine learning. Well, machine learning is basically kind of a technique where you can train software models using data. And so the model, or the computer program, kind of learns, quote unquote, learns from the training cases, and based on what it has learned from those training cases, tries to predict based on new data. And so computers are very good at making calculations. So we need to train it to perform the right calculations. So basically, our model is a function that best fits our data that we have learned it on, and then tries to predict new data based on the old data. And so now machine learning goes into even further subcategories as well. Under machine learning, we have supervised learning, unsupervised learning, and reinforcement learning. So let's start off with the first one, supervised learning. What exactly is that? Well, supervised learning is when we have labeled data. So let's say, for example, we want to classify our email, whether it's spam or not spam. When we have our data, our email messages, and we have those classified as that is not spam, and then we have a list of different emails, and those are classified as spam. And so we put all that data into our training model. It learns which the differences, which is what, and then we have our categorical classification model. And then we get those new emails, and then it tries to predict whether or not those new emails are spam or not spam. So we have labeled data, and then based on that labeled data, we try to create our model. Second, we have unsupervised learning. Now this is similar to what before, except we don't have our data classified. We don't know the labels for our data. We don't know if it's good or bad, if it's spam or if it's not spam. And we try to find those labels on our own. And so as you can see, we kind of have this data all in black. And based on human kind of interpretation, we could kind of see that there are about 2 or 3 groups. And so by using these clustering algorithms, we could try to find these groups and try to create our own labels from that. And so, of course, these clustering algorithms work based on the distance. How far are these points apart from each other? And so based on the distance, then we could try to classify how many groups of these clusters are available. Now here's a bonus one, semi-supervised learning. It's a combination of both supervised and unsupervised learning. It's quite a very useful technique sometimes as well. In this kind of situation, we have a few labeled data, but many unlabeled data. And so what we basically do is we first create a small classifier based on our labeled data. And then using that newly created classifier, we use that model to create new labels for the unlabeled data. And then we create a new data set with new labels. And so once again, after we have created those new labels for our unseen data, we recreate our classifier based on the newly labeled data to create a new stronger classifier. Because again, the more data that we have classified, the more data that we provide, the better the model performs. And sometimes this works a lot better in regards to other classifying techniques as well. And finally, we have reinforcement learning. Reinforcement learning is kind of a completely different category. Here we have an agent and an environment. The agent interacts within the environment based on some kind of defined actions. And so it learns based on a reward and penalty system. So if an action was choose whether to water or fire, the agent will randomly choose first go to fire, and then it learns, oh, minus 50 points, that's a penalty, you get hurt. So then based on that information, next time it knows it has to go to the water instead of the fire. And so by doing these trial and error type of situations, it tries to maximize that reward system to get as many, as the highest reward as possible. So that's reinforcement learning. Now, another kind of subcategory is deep learning. Deep learning is technically a subcategory of machine learning. Now, the biggest kind of difference kind of between deep learning and machine learning is that deep learning does not need any human intervention in regards to feature extraction. Usually in machine learning, a human has to create the features that later the model uses to learn. And so in deep learning, we don't need that human intervention. It does not need to know the feature extraction because it does that on its own based on the neural network system. And so the neural networks try to extract that those features, try to create those features on its own. Just a quick sip. And so one more thing about the magic behind deep learning, especially deep learning, because we can have one layer of neurons and we can have multiple layers of neurons. One layer meaning we have that one column of circles. And so we have multiple layers. The more layers of those neurons we have, the deeper the neural network is. And so each layer basically extracts information from the previous layer and learning more and more new information. So example, when we have image classification and learns how to classify images, then the first layer extracts, learns where are the straight lines, and then the second layer learns where are the curves in the picture, and then the third layer kind of gets a picture of a face, where are the curvatures, and then the final layer kind of gets the full picture and so on. So basically using those features from the previous layer, it tries to learn more advanced features as it goes along deeper within the neural network. Okay, so that's the end of part one. Now we're going to be going into part two, and then we're going to go into some details of how exactly we're using AI for issue ticket automation. So 1 second. Okay. All right, so using AI for issue ticket automation. So what exactly is the problem? Well, in every company almost, especially in software companies, there is no perfect company. Companies, when you're creating a software program, there are always going to be some kind of mistakes. There's no such thing as a perfect software. So no company is ever perfect. There are always going to be some kind of bugs that you can always find, some kind of problem, something needs to be updated, something needs to be fixed. And so these problems tend to occur. And testers are usually responsible for hunting for these bugs when they find a problem, and someone has to then later fix it once the problem is found. But the biggest problem is who should fix the bug? See, because there are many teams, usually companies have many teams, and each team is responsible for one specific either component or some kind of task or some kind of part of software or hardware or whatever it may be. So each team is responsible for something, and someone has to fix it. But the biggest usually question is who has to fix it? And so at times it can be very confusing, especially when you have many teams. And so with this problem could be easily solved with the help of AI. There are multiple tickets being raised every day, but looking at past tickets, we can see where each ticket ended up. So we can basically see, take a look at the historical data, see, okay, this ticket had a problem with the front end. So this ticket goes to team A. And this ticket had a problem with the back end. So this ticket goes to team B. And so by basically analyzing the information from these tickets of what exactly the problem was described, then we could assign to the correct teams. And of course, because this is a computer analyzing these problems, and especially artificial intelligence, we could do this instantaneously. We don't have to look through thousands of previous tickets from the past months and see which is the most similar ticket to the current problem that we have. No, because this is a computer and the computers can do this instantaneously. And so for artificial intelligence, in order to be able to analyze text, we have to use natural language processing because as you know, computers don't speak normal language, they speak in binary code. So now, what exactly is this natural language processing? Well, it's the ability to program computers so that they could process and analyze large amounts of natural language data. So basically, the language that we are speaking today, whether it's English, Polish, whatever language it may be, the natural language of us humans, basically. And so NLP helps computers to understand and interpret and manipulate the human language. So being able to translate those texts, those words into binary code, so zeros and ones, so that the computer can then later understand. And so NLP basically has tasks of breaking down the language into shorter pieces, so into words, characters, phrases, and so on, and tries to understand the relationship between those two different words and the pieces that they work together and how to create some kind of meaning. And so, of course, some examples of natural language processing. NLP helps to extract meaningful information from data using various text mining techniques. And so some examples would be sentiment analysis, whether some kind of text was good, bad, or so, for example, reviews on IMDb or on Netflix, whether that was a good review, bad review, and so on. Content categorization, classification of news topics, whether it's sports, whether it's politics, technology, and so on, and even going to maybe more specific types of different subcategories of classification of topics. Speech recognition, that also applies to natural language processing. So when you use Siri, Alexa, Google, that also requires natural language processing. And of course, machine translation. So Google Translate, being able to translate from between different languages, that of course has to also apply natural language processing. Now, how exactly do you do this natural language processing? Well, there are a couple things that you really have to do. First off, we have to start off by preparing the data. You can't just give it the full sentence in English and expect the computer to understand. No, you have to properly prepare the text so that the computer can understand. And especially when you're using machine learning, not deep learning, but rather machine learning, so rather shallow kind of networks. This requires a lot of feature engineering, so creating features by the human. And so some of the things that we really have to do is keeping only words, so getting rid of punctuation, commas, exclamation points, any other kind of special kind of characters, and just leaving regular words in text. Converting all words to lowercase so that they're all the same. Removing stop words such as again, mostly, and very similar words like that. And using stemming words and lemmatization of words. And what that basically means is kind of getting the root word of different words. So if I said, I ran to the store, instead of using ran, that would be transformed into run. So getting the base word, the root word of each word, because that enhances the machine learning model. It better understands when it has only the root words. So it doesn't get confused as much. Feature engineering. So after we've kind of prepared our data, now we have to kind of create these various features that the machine learning model will use. And so some of these kind of features that we kind of create would be, for example, the word count. How many words are within a sentence, within a paragraph, within a document, length of the longest words, the shortest words, words with numbers count, word ratios, so how many unique words within a sentence, based on how long the sentence is, how many special words, maybe features or errors that are being mentioned, mean word length in characters, character count, punctuation count, that's sometimes could be useful in certain situations, frequency distribution in parts of speech, so whether it's a noun, or it's a verb or adjective, those are also very helpful information for the computer as well. And of course, once we have those words, we have to convert it into a certain representation that the computer will understand again. So again, we have cleaned up the data. We have only our words that matter the most, but still we're not done yet. We have to now convert those words into our kind of binary format for the computer. And so some of these kind of techniques would be such as using count vectorization or even TFD, TF-IDF vectorization. And so count vectorizers is basically converting or counting how many times a certain word appeared within a sentence. So, for example, we have good movie, then we have good has one, movie has one, and then all other words that did not appear within that sentence have a zero. And so similar for all other situations. So we have this kind of bag of words, so this kind of dictionary of all the words that are appearing within a document, and just tallying how many times a certain word appeared within a certain sentence or paragraph or whatever it may be. So that's count vectorizers. And then we have TF-IDF vectorizers, which is something similar, except it has this unique kind of feature functionality, which is the inverse frequency count. So basically, we have a lot of different words, and sometimes words like a, the, that, they quite often tend to appear within text. And so those are, even though they appear very often, they're not very important. And so for the model to kind of understand that those words are not important, and words that are more important are the words that appear less frequently, we use this inverse kind of frequency count. So we basically inverse it. So the more times a word appears, the less important it is. And so that's how we could find which words are most important. And actually, TF-IDF is actually used, for example, in Google searches. So when you search for a certain topic, or you want to look for a certain article, and using those keywords, it uses this TF-IDF vectorizers to see which articles have those words or have those most important words, because we don't care anything about anything else. We care only about the most important words. Once we have created our features and everything, again, in machine learning, an extra step usually is feature elimination, and that is to eliminate any unnecessary features, because too many features can actually overfit the model. Overfitting meaning that the model will not learn anything new. It only learns to the models, to the training data, but it doesn't really learn anything new. And so to minimize that and to eliminate any unnecessary features that we may have created or that does not increase the accuracy of a model, we could use feature elimination or selection kind of techniques. One of them being such as recursive feature elimination, selects k-best, select a percentile, and so on. And so basically, it iteratively removes various features and checks the accuracy, whether or not it has increased or decreased. So this is a very time-consuming, but it can sometimes help. Then, of course, after we have created all our features, then it's time to explore the different types of models. So basically, because we don't know which model will best work, so we have to try out various different types of models to see which one works the best and kind of eliminate the weakest and choose the best working models. So some of these models could be naive Bayes is a very popular model used for NLP, logistic regression, SGD classifier, and of course, then later more advanced shallow networks, convolutional neural networks, and LSTM, so long short-term memory. And of course, after we have created and trained our model, we want to understand the results from our model, and so we want to use these various techniques such as SHAP, so shapely additive explanations. And basically what this does, it's a very nice library which allows us to generate which features have the greatest impact on the various decisions. So if we're having some a classification, such as whether it's good or bad, then we can see which features have the greatest impact, whether on the classification of if it was good or if it was bad. So basically saying which features had the greatest impact on going left or right. And of course, after doing all of that, we got quite decent results. The results were quite good, but of course, there are some challenges always that you have to face. It's not always sunny and sunshine all the time. There are usually problems that usually occur, and some of these problems are such as the classes are imbalanced. So the various amounts of tickets that are being assigned to different teams are not always the same. One team will get more tickets than the other, and so we don't really have again, enough data from each team. So this, again, covers the second point. We don't always have enough data, and so for certain teams, especially if they have a lot less data, a lot less tickets being issued to them, then it's hard to really classify or to be accurate to classify to that specific team. So again, these are kind of typical problems usually found in these kind of projects. Improper classifications. A ticket might have been assigned to team A, but then later it turned out it needed to be assigned to team B. And so these kind of misclassifications can also impact the model if they are not caught and they are not cleaned properly. And of course, data analysis is time consuming. You can't just throw all the data into a model like a blender and hopefully you get a nice fruit smoothie out of it. Nope, that's not how it works. You have to really analyze the data, see if it makes sense. Does the model make sense? Is it making the right predictions? What kind of maybe new features that could be generated from it? So there's a lot of time-consuming tasks that you have to be done in order to do this data analysis. So that's basically how the current project looks like, and so it has certain limitations. So what exactly are we going to do next? What are some future plans for our project? Well, the next part that we kind of want to try to add to our project is really log analysis. So whenever you do submit some kind of ticket to a team, usually it requires also adding some kind of logs so that the team could analyze what exactly really happened and then be able to actually find the problem. So not always the description is good enough. Usually you have to add those extra logs. Except what to expect from these logs? Well, usually a lot of specific and technical language is used within these logs, and you can't find really this information on the internet. It's very domain specific. It requires domain knowledge to know what to exactly correct. So again, in order to find the problem, can't be found anywhere. And of course, AI requires a large amounts of logs to learn from. So being able to collect this data is also very difficult. It has to be stored somewhere. It takes up a lot of space sometimes, so it's quite difficult sometimes. And so in general, it's just hard. Analyzing logs, especially manually, I know because I was a tester myself and I had to analyze logs before. It's hard. It's not really easy, and it's just hard. I'll leave it at that. So, but the question is, if we want to do this, then the main question is, can AI be used effectively for log analysis? And the answer is yes. And this was actually done by DeepMind. If you don't know DeepMind is a very popular company that mainly focuses on reinforcement learning. Some of their popular projects was Agent 57. They created a reinforcement model. Excuse me, a reinforcement model that was able to beat all of Atari's games without any problems. That was like the first project. Then they had AlphaGo, beat the world champion in the ancient Chinese board game, which is very difficult to play. And their latest project, which was Alpha Star, and they even beat the best players with StarCraft using an artificial intelligence. So really amazing achievements by this company. And so what exactly did they do? One of the biggest problems in regards to optimizing energy and consumption is data centers. Data centers take up a lot of energy because all the computers and the systems to cool the system and many other kind of technical things that are needed to run a data center is very consuming a lot of energy. And so this was kind of one of the biggest problems and one of the challenges that were taken upon by DeepMind to try to minimize those energy costs by the help of AI. And so the goal here was to use AI to set the right configurations in these systems in order to maximize or to lower as much as possible the energy consumption whenever it was not needed. So how exactly was this actually done? What exactly happened was when we have these systems, logs are being collected, and these logs are usually called snapshots. And just like it is called, it's a screenshot or a frozen in time of what exactly was happening within the system. And we see this within our logs. They took those snapshots and they fed it into an AI system. Of course, preparing it appropriately, formatting, cleaning, and so on, and they fed that information into an AI system. And so the AI system then later starts playing around with the configurations to see which configurations gave the most optimal energy output. And so those configurations were given to a safety system first as a recommendation of set these parameters so that nothing crazy happens of setting the temperature to 100 degrees or anything like that was done. So just to be safe. But it did provide some kind of configurations that would optimize the configuration, the optimization of energy, and so then that was later applied to the systems. And so there was proof here, as you can see in this chart, that whenever the machine learning, so ML control was off, the energy consumption was very high, but then once they turned it on, it greatly decreased. And so again, when they turned it off, the energy consumption went back on. So there was a big improvement. And so they were able to, I think, reduce up to 30, 40, and maybe even 50% of costs using this AI automatic configurations kind of system. And so as they continue to collect more and more data and train the neural networks, the AI model based on more and more data, the more accurate the model became, and then the more energy was optimized as well. So the more data, the better the model trains as well. So that's one of the greatest kind of functions there. So since AI is so great, will it replace testers? I say nope. But that is just my personal opinion, of course, and here's why. Artificial intelligence is not that intelligent as it may seem. Even though it could do all these great kind of stuff, it's still it's not perfect. It's not good enough for creating Terminators or anything like that. It cannot fully replace humans. So there still needs human intervention to guide this AI. But instead of replacing AIs, I see AI really as working side by side with testers, with humans all the time. So instead of replacing them, AI is going to be like this third arm for typing faster, or this second head for thinking better type of kind of situation. So I don't see AI being replacing anyone, especially testers. I see it as improving or enhancing the work of many workers and making life maybe a lot easier, maybe increasing the quality of work as well, but not replacing. So that's nothing to worry about. And of course, with the help of AI, having a lot more free time, maybe AI will help us to get us more free time to go on coffee breaks, to talk with our colleagues, and so on. So that is everything for my presentation for today. Thank you very much for listening, and I hope you enjoyed it now. Alrighty, Daniel, thank you very much for that presentation. That was such a great presentation. One of my favorites. I absolutely love artificial intelligence, so that was really great to see. So thank you once again. And hopefully everyone had their presentations, their Discords open for asking questions. So please write your questions if you haven't written your questions, and let's see if anyone has written any questions. Okay, maybe we could start off with the first kind of main question is, how can you get started with machine learning? And that is a really great question. Some great ways. The first thing I would say, YouTube is your really best friend. There's a lot of free content. A lot of people are really creating introductory videos on YouTube. So I think YouTube is really a great place to start. Of course, moving along, there are different courses that you could take. Coursera is a great place. Andrew NG, you cannot forget about him. If you don't know who Andrew NG is, then jokingly saying you can't be called an ML engineer if you don't know who Andrew NG is. So I highly recommend listening to his courses on Coursera, for example, or Udemy. Some books I could recommend. The best book I can recommend is Hands-On Scikit-Learn and TensorFlow, I believe it was called. A really great book. Lots of great tips presented in that book. So that's really great to read, depending what kind of learner you are. If you prefer learning books or if you learn based on video, that depends on you. But more books, a lot of great books are on O'Reilly as well. So I highly recommend that area of books. So that's my recommendation for starting on machine learning. Okay, let's see. Any other questions? Okay, do you have working prototypes, products, which leverage AI, and do you use it for issue ticket automation already? Do you have working prototype products? Yes. Yes, this is actually a current project that we are currently working on, and is actually in use at the moment. So yes, by all means, this is a working kind of prototype, constantly evolving project. So we're constantly improving the quality of this AI model. So it is being used in our issue ticket automation already today as well. So that's that. Thank you for that question. And let me just move this so you see better. How do you know if you have enough data? Oh, no, that's a very good question. You don't. It's hard to say when enough is enough. It really depends on the situation. It depends on the type of project. Usually you don't need that much data to get started. To get started, you don't need that much data. But the kind of general rule of thumb is the more data you have, the better. Actually, there's kind of a cap when you use a machine learning techniques, so not neural network techniques. Then there's a cap of the amounts of data that can learn on. So a certain amount, it starts to saturate the model. But for neural networks, that's a different situation. The more and more and more data you have, the better it learns. Except, of course, you have to be careful. You have to monitor the data. Is it good quality? Is it not confusing the model in any way? So when is enough? It's hard to say. It's really hard to say. But the more, the better. That's my best recommendation. Another maybe suggestion would be to analyze metrics to see how well the model is performing. If it's performing good enough, then I guess you have good enough data. So thank you for that. We have another question. What are the main obstacles talking about NLP specifically? How to test it? Okay, so this depends again. This depends. What we're working on is kind of very specific, domain specific. There are a lot more advanced kind of techniques that can be used, but maybe are not really used in our research that we're doing. For example, popular models are word embeddings. BERT, for example, transformers, those are very popular right now. And so the key thing behind NLP is trying to best understand the data. So BERT has this kind of magical kind of property that it learns the context of sentences. So when words are next to each other, does it make sense? So if I say, I bought an Apple iPhone and I am eating an apple, that the model is capable of differentiating between an Apple iPhone and an apple fruit. So those are kind of like the biggest challenges in NLP is trying to understand the text. And so these word embedding kind of systems and models are being constantly created to advance in these areas. And there's hundreds of different types of models of BERT, Roberta, or I can't even remember how many there are, but there are many, just many. So the biggest challenges in NLP is to try to understand. But thank you for that.